Hello everybody, in this lesson I will introduce the cyclic quadrilateral theorems. A cyclic quadrilateral is a quadrilateral whose vertices lie on a circle. Angle S and Q are called opposite angles of a cyclic quad PQRS. P and R2 are also opposite angles of a cyclic quad PQRS. Chord QR is produced to form an exterior angle R1 of PQRS. R2 is R1's interior adjacent angle and P is R1's interior opposite angle. Now the first theorem says the opposite angles of a cyclic quadrilateral are supplementary. Remember, the word supplementary means they add up to 180 degrees. Now let me quickly introduce the abbreviation that you may use in the exam. Opposite angle cyclic quad. Now let's go to the sketch. This theorem then implies that angle P plus angle R2, they are supplementary. And you can also say it the other way around. You can say angle Q plus angle S, they are supplementary. Opposite angles cyclic quad supplementary. We also find the converse for theorem 4, and that reads, a quadrilateral is cyclic if its opposite angles are supplementary. So it's the exact opposite of the previous theorem. And then the short for that is opposite angles of quad supplementary. Then there's also a corollary which states that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. And that means that R1 is equal to angle P. And the short for that one, exterior angle of cyclic quad. So now on your cheat sheet, you can add on the right hand side the two theorems on the cyclic quadrilaterals. The first one, the opposite angles of a cyclic quad, they are supplementary. And then this other one, the exterior angle of a cyclic quad is equal to the opposite interior angle. Let's look at some easy examples. Let's start with some easy riders just to get you going. Find the size of x or the variable in each circle with midpoint O. Give reasons for all statements. Now, my advice to you is start with the given angle. So in the first sketch there, you will see that O is 150. That one is given, which brings me to angle A is 75 degrees, and your reason will be angle at center is twice angle at circumference. So the one on the outside on the circumference is the smaller of the two angles, which brings me to B is 105 degrees, and your reason is opposite angles of cyclic quad. Can you see A and B, they form the opposite angles, and remember, they're not equal, they are supplementary. In the next sketch, you can see that there's angle A, which is 70 degrees, and then there's also DC parallel to AB. So you're going to use that. We can start by saying that angle D is equal to 110 degrees, and your reason is co-interior angles supplementary because DC is parallel to AB, which leads me to angle X is 70 degrees, and your reason opposite angles of cyclic quad. Can you see there? They are the opposite angles and they are also supplementary. In the next one, ECB, that tiny little angle there is 65 degrees. And your reason is that exterior angle of a cyclic quad is equal to the opposite interior angle. There at angle A, that one, that's the exterior angle, is equal to the opposite interior angle. Then angle EBC is equal to 90 degrees. If you look at that little triangle there, it's angles of a triangle. And then you can say that angle X is 90 degrees and your reason is angles on a straight line. Again, let's start with the given angle, and we have 106 degrees there, and we also have two parallel lines. So we start by saying that G is 106 degrees, and your reason is exterior angle of cyclic quad is equal to opposite interior angle, which leads me to I, and I is 74 degrees, and your reason is co-interior angle supplementary, remember? And then you can say that angle H is 106 degrees there, and your reason is opposite angles of cyclic quad supplementary. In the next sketch, you have to focus on a triangle ADE. There's two angles given there, so therefore angle ADE is 100 degrees, and your reason is angles of a triangle supplementary, which leads me to angle B over there, or angle X rather, which is 100 degrees, and your reason will be exterior angle of cyclic quad is equal to opposite interior angle. And then the last one, we find that angle B is equal to 70 degrees, and your reason, exterior angle of cyclic quad is equal to opposite interior angle. Therefore, angle X is 140 degrees, and your reason will be angle at center is twice angle at circumference. In the next lesson, we will look at more difficult examples on cyclic quadrilaterals. Click on the video in the left-hand corner to take you straight to the next lesson.